Okay, hello, Mr. Reed here again. We're going to do number 5 and 6. So number 5, we're dividing n to the 6th, divided by n squared. So hopefully by now we realize all we're going to do with these is subtract these because we have the same base, n and n. We're dividing, so we're just going to subtract 6 minus 2 and get n to the 4th. That one, we're going to do the same. This one's a little different. So we've got a to the negative 10. So if we have a negative exponent in the numerator, we know we can simply take that to the bottom. So that's going to give me 1. So I'm taking, because this whole thing right here, this whole thing right here has to go to the bottom. So that becomes a to the 5th, a to the 10th. So now once again we're simply going to add those together and get a 1 over a to the 15th. So that's number 5 and 6. Okay, we have number 7 here, radio signals, and we're in, we want to do this in scientific notation. So we have 3 times 10 to the 8th, and we also have 3.6 times 10 to the 7th. So they travel at a rate of 3.3 times 10.8, or 10 to the 8th power meters per second. How long will it take a radio signal to travel from satellite to the Earth? The satellite is orbiting at 3.6. So what we're going to do with this, we're going to take our 3.6 times 10 to the 7th, which I get from here, right there. We're simply going to divide that by 3 times 10 to the 8th power. So our first step, of course, is we divide 3.6 by 3, and that gives me approximately 1.2. And here we're simply, we have this whole piece here, so we're simply going to subtract 7 minus 8, and that'll give me times 10 to the negative first power. And that's it for number 7. Okay, number 8. You know, it's another word problem, and they get all this crazy stuff in there. Scientists, a black hole. We don't care about that. How many times? Well, how many times more massive than the sun would a black hole be? So we've got these two things to consider. 7.36 times 10 to the 36th power, and the mass of the sun 1.99 times 10 to the 30th power. So again, we're going to be just doing a little division, come up with a quotient, times 10 to the 36th power, and we're simply going to divide that by what they give us right here, 1.99 times 10 to the 30th power, and of course what we have to do first, change colors, we're going to divide this piece here, and that gives me 3.6, I'm going to round 9, just leave it at 9.8, or we could, it keeps going, but I'm just going to round. And then of course we have this portion here, which we're just going to subtract just from our rules, 36 minus 30. That's going to give me my answer of, I'm going to bring it over here, 3.698 times 10 to this 36 minus 30 is 6th power. And we could have actually rounded this whole thing to 3.7 depending on where we were looking to round to, if the rules told us what we're supposed to do. But there you go. Okay, a couple problems, pretty straightforward. First one, we're going to take this whole thing right here to the 4th power. So the first thing we have is 3 times 3 times 3 times 3, which is 81. And then it's simply x to the 4th power divided by 2 down here, 2 to the 4th power, which is simply 2 times 2 times 2 times 2, which is 16. So that's it for number 9 right there. That's simple. Change colors here and we'll finish up with number 10. Same thing, we don't have any negatives to worry about, so we're going to do this first part. And that's going to give me m. Well, we got a power raised to a power, so we're multiplying, but in this case, same as adding, but we are multiplying. Divided by, well, we got to take this whole thing and square it. 10 squared is 100. And j to the 5th power squared is 5 times 2, which is 10. So my answer for number 10 is right there. And that's it.